Hi, my name is Ken Johnson. I'm Director of Marketing and Product Architect at LeCroy.com. In this video, we're going to give a short demonstration of complete drive system embedded control and power section testing using the Motor Drive Analyzer. This is a lab notebook of a surgical tool that reverses direction once per second. At the top are two of the drive output voltage phases. The currents are not shown, but there are two currents acquired as well. The red signal is from the control board and it indicates shaft angle. The light blue signal is from the embedded control system. It triggers the beginning of the reversal on the rising edge and expects the end of the reversal to be completed by the falling edge. The green signal falling edge indicates the maximum time that the reversal may take. The orange signal is an analog speed feedback signal from the embedded control system. The blue trace at the bottom is per cycle speed calculated by the MDA, and a magenta trace is per cycle three-phase power also calculated by the MDA. We'll turn on cursors, and you can see that the motor reversal registers as near 0 RPM or 800 millirpm, and the drive output power registers as about 700 milliwatts during the reversal. You can also easily see the dynamic variation in speed and power output, which is not obvious in the mean value numerics table. This example shows validation of a deadbeat direct torque and flux control drive system. The signals on the left are all part of a 200 millisecond acquisition, and the signals on the right are 40 times zoomed or calculated math traces based on the zoomed area. In the dB/dTFC method, the control system adjusts torque within one semiconductor device switching cycle, and we correlate power and control signals to validate the operation. At the top is the torque command issued to the control system and the torque estimate created by the control system. Below are the command and sense voltages generated by and sensed by the control system. The drive output PWM signal for one phase is shown at the bottom. To the right, we zoom in and see that the torque estimate is received within one device switching cycle, as desired. Below that, we can see command and sense voltage difference, about 1.5 volts, also within expectations. At the bottom, we've calculated the DC value of the PWM output voltage per device switching cycle and subtracted that from the signals above to determine the voltage error at the drive output. The error is 2 volts or less in about 160 volts DC or RMS, also acceptable. Thanks for joining us for this video on complete embedded system and drive section testing using our Motor Drive Analyzer. You can watch additional Motor Drive Analyzer videos or access additional content at LeCroy.com/static-dynamic-complete.